So in this lesson, lesson 1.5, we're going to be learning about what we call cumulative distributions. And you might be thinking that there's a common theme here. We've looked at bar graphs, we've looked at histograms, we've looked at box plots. Now we're going to look at cumulative distributions. So again, a lot of this chapter is just different ways that we could represent data and our statistics and be able to look at that information to draw conclusions. So let's look at this situation. It says a function whose values are cumulative frequencies or cumulative relative frequencies is called a cumulative distribution. Well, what does cumulative mean? If you think about in Minnesota, we deal with a lot of snow, and so oftentimes as we get to the end of winter, they'll talk about the cumulative snowfall. That's just referring to how much snowfall total has fallen up until that point. So that's what a cumulative amount means. It represents the total up to a certain point. So let's look at this table and this graph that they've done for us. So this is looking at the normal precipitation in Los Angeles, California. The column of the table shows a total or cumulative, or the second column of the table shows a cumulative precipitation for the year up to and including the month. The graph is complete, but some values in the table are missing. All right, so the first graph, that's just a normal bar graph. Okay, that is not a histogram. Now you might be saying, but the bars are right up next to each other. Well, remember, a histogram would have, along the x-axis, would have a numerical variable. These are just comparing months. Instead of having a whole bunch of space, they just put these months and butted them right next to each other. So that's a normal bar graph. And so what we're going to do, though, is we're going to create a cumulative distribution of that data. So what they've done on the right there is with that table, they've given us each amount of precipitation that occurs each month and then the total through the end of that month. So you can see that in the month of January they had 2.4 inches. So through the end of January we had Los Angeles had 2.4 inches. Now in February they had a little over 2.5 inches of rain. So if you take 2.51 plus 2.4, you'd get 4.91 and so on. So what I want you to do, if you notice, there are two values missing in this table. So I want you guys to figure out what would be the values that would go in those two boxes. Why don't you pause the video and go ahead and see if you can figure out those two values, and we'll check that in just a second. Alright, so for this first value here, we know that through the end of May we had 7.75 inches, and then in June they only got 0.03 inches, so 3/100ths of a tenth, or 3/100ths inches of rain. And so if you add the 0.03 to 7.75, we get 7.78. And then later, to figure out how much rain they got in November, just in November, well, we know through the end of October we had 8.59 inches, and through the end of November we had 10.35 inches. So to find out how much rain fell in November, we would subtract those two. And the difference would give us 1.76. And so there's 1.76 inches during the month of November. So then what we're going to do is we're going to create a a bar graph for this data, but we've already got a bar graph for the regular precipitation by month, so we want to create a bar graph for the cumulative precipitation. So that's what we're going to be doing here, and then we're going to answer parts C and D for that question. So what I want you to do is I want you to copy this information down, so I want you to get your graphs to look very similar to what I have. And so along the y-axis, we're just going to count by twos. And so we have to go up to at least 12. There's a little over 12 inches of rain there, so 12 would be fine. And so why don't you guys go ahead and copy this down into your notes. And then now I'm going to scroll up so you can have that data if you didn't get that copied down. And so you're going to graph this data into that bar graph. So pause the video and hit play when you're ready to check to see if you've done that correctly. Alright, let's see how you did here. So your graph should look something like what I have. Doesn't have to be exact, but it should be pretty close to what I have here. And now we can use this graph to answer these questions. So when it says, when has half the yearly precipitation fallen? Remember, well, we had just a hair over 12 inches. We'll just say 12. And half of 12 is 6. And so when I look at this, we see that during the month of March is where we reached half of our annual rainfall. And then when it says, when has 3/4 fallen? Well, 3/4 of 12 would be 9 inches. And so here's approximately where 9 inches would be. So that would be during the month of November. So we can interpret that different ways. We could say, for example, that during the first 3 months is when half their annual rainfall is when they get during the first 3 months. That means that it takes the rest of the 9 months to get the other half of their rainfall. And the last 2 months is where they get to about 25% of their rainfall. So there's a big stretch you can see during the summer months where they don't get a lot of rain. So that's how you can interpret that. So that is how we create a cumulative distribution or cumulative bar graph. So what we're going to do is we're going to look at the next table on this next page. And what I want you to do here is we're not going to worry about creating a bar graph. It's going to be just like the previous one as far as the process. What I want you to do, though, is I want to make sure you understand how to get the cumulative amounts. And so that's what you're going to do in this one. You're just going to write out these numbers. So, for example, the first month would be 1.13. And so you're just going to start from there and figure out the cumulative amounts. And I'll just tell you, if you get to the end, you should get an answer of 35.51. So why don't you go ahead and pause it and make sure that you get those values. So double check, make sure you got those numbers right, but as long as you came up with a total in the end of 35.51 inches, again, this is for Kansas City, Kansas, their cumulative rainfall. Big difference from the 12 inches that LA got versus this one, almost 3 times as much. All right. So in this one, we're going to fill in this table. Hold on, went too far here. So we're going to complete this table. So this is dealing with this story problem where it says, let me scroll up. Here we go. At 5 a.m., a sudden snowstorm caused Oak School to cancel classes. With no automated message relay system, news had to spread word of mouth. The table shows how many of the 170 families knew about the closing from 5 a.m. to 8 a.m. So so we know the total numbers. We know the cumulative amount. So by 5:30, 6 families have been notified. And then by 6, now there's a total of 14. So we want to figure out how many people were notified at that 6 o'clock time and so on. So I want you guys to complete this table. And then we'll go ahead and answer these questions. So one of the things that you're going to do is instead of creating a bar graph, you're going to create a line graph. And so basically it's the same idea except for you're just going to plot the points and then for the cumulative amounts and then connect them with straight lines from one point to the next. And I'll show you what that looks like with your final answer. So go ahead and I want you guys to complete all of this one on your own. All right, so hopefully you got these numbers. That's not too difficult, but you just had to find the difference there to find the number of families that have been notified during the preceding half hour. So you got 8, 34, and 16. And I hope I didn't confuse you by those. I noticed after pausing the video that it had some green lines. I think I shifted the graph a little bit. And so those green lines randomly showed up at those different places that looked a little weird. So hopefully that didn't throw you off. But so we have these points that you would graph then for your cumulative amounts. And you just connect those with a straight line to get a cumulative line graph. Now let's answer the questions for C and D if you didn't already do that. So it says, when had half the families been notified? Now there's 170 families total, so half of 170 is 85. So there's a couple ways that we could look at that. We could look at the graph, and we look at the graph 85. So if this is 90, 85 would be halfway between 80 and 90, so it'd be right about there, which we could estimate that. So this is, if this is 630 and if this is 7, that means this would be about 645. So your answer here would be somewhere around like 640. So we could estimate that time. Then it says, when had 3/4 of the family been notified? Well, 3/4 of 170 would be 127.5. And so obviously we're not going to have a half a family, but we're just going to use that as a reference. It'll be somewhere around 127 families. So if this is 130, so 127 is going to be close to that. So we're going to look at this value. So that's a little bit past 645, so maybe you just estimate to be about 655. Doesn't have to be perfect. If this were a test question, I'm not going to have like 650 and 655 and 657 as choices. As long as you have the right, close to the right answer, you'll be fine. All right, well, let's end by looking at this concept called a percentile. Forgot to type that and include that in here, so you need to write that in if you have my notes printed out. Otherwise, if you are writing this down in your own notebook, make sure you write this down. Because percentiles, this is a new concept for you. A percentile is defined as the pth percentile is a value where p% of the numbers are less than or equal to that value. So, for example, let's say if you take the ACT exam and in your results they say that you're in the 80th percentile. Now, some people will be like, oh, a B, 80% is a B. No, 80 percentile is really good. That means that 80% of people got your score or lower. So that means only 20% of the people got better than you. So hopefully you can look at that as a good thing. So that's what a percentile means. So you oftentimes will also see percentiles someday when you have children. And you'll go into the pediatrician and they'll say, oh, your child's in the 60th percentile for weight. Well, some people might be like, oh man, that's really bad. No, that actually is pretty good. That means 60% of babies are that weight or lighter, and 40% are heavier than your child. So being in the middle sometimes is a good thing. So if we were looking at this problem and it says what time represents the 90th percentile, well, what we do is we would figure out, well, where would 90% of people be notified? What value would that represent? Well, 90% of 170 people would be 153. So the 153rd person would represent that 90th percentile. And if you wanted to figure out where approximately that would end up being, well, 153, if this is 150, 153 would be right about here, which is pretty close to that 7 a.m. time. So that's how you could interpret that. So that is how we find percentiles. You take the percent of a particular value, and then that will tell you where that percentile would be. Because you will have some questions like that in your homework assignment, which we'll deal with tomorrow. So hopefully this video cleared some things up and to help you understand how to find a cumulative amount. If you have questions, make sure you bring those questions to class tomorrow.